Welcome everybody. Welcome to our 6th lecture in our microcontroller course, especially for BrightSparks. And in this lecture, we're going to look at some more. We've done a little bit of output already, but we're now going to look at more outputs from our microcontroller and inputs into our microcontroller and how we read them and handle them and program them. But first of all, I'd like to look at the task I gave you to do. This isn't school. I know that some weeks are too busy to get down to this, no problem. But for those of you that manage something, I'd love us all to look at what you managed, and then we can learn from each other and see the various ways that this problem can be solved. And I'm sure that there will be quite a few, well, as many ways as we have people present today. So let's first just remind ourselves what the plan was. I wanted you to connect up your nano, the ground to the ground rail, the positive 5 or VCC to the positive rail, and just for consistency, we'll put our breadboard down with the plus at the top and the minus at the bottom. Otherwise one can get confused. And then I wanted you to connect these pins of the nano to as sources. So in other words, they're going through from the controller, through the LED, through the resistor to ground. So they are acting like a source. And I'd like you to connect pin D2, D4, D6, D8, D10, and D12 to these 6 LEDs. And through the LED, through the resistor to ground. Fine. And then I suggested some ways to do things. Firstly, let's just call them LED 1, 2, 3, 4, 5, and 6. So in a row. And so my first task, what I tried to show here, is switch on LED 1, switch it off, switch on 2, and as you switch on 3, switch off 2, as you switch off 3, you switch on 4, and so forth. So it'll be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 is how our LEDs will light up. Then for number B, I suggested that you light up LED 1 and then keeping it lit, switch on LED 2, and keeping 1 and 2 lit, switch on LED 3, and keeping 1, 2, and 3 lit, switch on LED 4, and so forth, up to 6. So this will look like a bar graph growing from the bottom up to the top and then starting at the bottom again. And then I'd like you to do just like you did for A, but go up and down. So we go 1, 2, 3, 4, 5, 6, 5, 4, 3, 2. And because we're in a loop, we 1, 2, 3, and so forth. Then, just for fun, 1, switch off. 2, switch off. 3, switch off. 4, switch off for a period. And then 1, switch off all the way up to 6 and then back down again. Okay? And then we'll have this rolling snake, as it were, snaking up and down our LED line. So we have 1, 5, and 6 burning, and then 1, 2, and 6, and then 1, 2, and 3, 2, 3, and 4, 3, 4, and 5, 4, 5, and 6. So you'll see it'll be 3 LEDs making their way up and then starting at the bottom again, and so forth. And for G, going down, 4, 5, 6, 3, 4, 5, 2, 3, 4, and so forth. So the 3 LEDs chasing each other's tail downwards. Okay, so I'm going to pause the lecture now, and we can share with each other our various homework attempts, or not attempts, I'm sure you succeeded, but the various ways that you did your task. Right, that was fun. Now let's look at a short piece. This will be relatively short because we've spent our time on evaluating the task. And we are now going to do a couple of ways in which we can input and output data from our microcontroller. Right, so I would like you to take out your breadboard, and there we are. There's our breadboard, and we have connected we've connected this positive to the positive rail, the yellow one, and the ground to the negative rail, the blue one. So we are feeding our Arduino Nano from our computer, and we have powered our 2 rails so that we can build something on it. Right, so I'm going to unplug our Nano so that we don't work on it while it's powered. It's better that way. Right, so now I'd like you to take a jumper and go to pin 2. That looks right. And now just make sure that the focus is optimal. Right. And now we've plugged in a jumper into pin 2, but we haven't plugged it in anywhere else yet. So let's have a look. We now go to our IDE, and we load open BrightSparks digital input. Okay, so there's our program that we're going to be using now. Okay, now you should have seen a lot of this before. We have our setup, which runs once. We initialize and start up our serial link to our computer so that we can print out stuff and see what's happening. And then this is a little bit new. Pin mode, pin 2, input. We've had output up to now, but this one, pin mode, input. So we are defining pin 2 as an input this time. Okay, so in our loop, we declare an integer, I, and we say I is equal to digital. Now we've had up to now digital write. Now we have digital read. So it's digital read pin 2. Okay, so whatever pin 2 is, it will now be in I. Okay, so we want to see what it is. So we serial, and serial knows a couple of things, how to do them. One of them being print line. Okay, so the serial, this is called a class. The serial class knows about printing a line. So serial dot print line and print our value I. And then, just so that things don't rush by too fast, we delay a little bit and then we go through the loop again. So we are going to see various values rushing by on our serial monitor. Okay, so I'm going to plug in our camera, Arduino Nano, and now I'm going to switch the camera on and switch to that mode, and there we have it. Right, so I'm going to start off by taking our jumper, okay, and I'm going to plug it into either the positive rail or the negative rail, okay, and that then is busy inputting that value into our Nano. Fine, so let's upload this sketch. Okay, that's uploaded. Now I'm going to switch on our serial monitor. Okay, and we see it's showing a whole lot of zeros. And now watch as I plug in to our negative rail. Still zeros. Plug into our positive rail. Ones. Plug into our negative rail. Zeros. Plug into our positive rail, 1. So it works very simply when our voltage on that pin, which has been defined as an input, when our voltage is close to 5 volts, then we read a 1. I becomes 1, in other words. And when our voltage is close to 0 volts, then we read 0. Okay, it's all a question of digital. Digital is anything that has that you can count on your fingers. That's where digital comes from, and it's basically anything that has a binary possibility. So the possible options are on and off, or light burning, light off, or 0 and 1, or true and false, or male and female. Everything that has only 2 possibilities lends itself to be expressed in binary form. And so here we are, binary 0, binary 1. Okay? Now, you've noticed that a couple of times I've said a voltage around about ground, or 0 volts, or voltage round about positive 5, or VCC. Okay? I've never wanted to be too specific. Okay? There's round about 0 and round about 5. And I've never wanted to be too specific, and for a specific reason, because that's how binary stuff works. So let's do another little experiment. I'm going to move that out of the way, and we're going to look at this guy. You'll see him in your bag of tricks. Okay, that's called a potentiometer. Okay, and the potentiometer is a resistor between that leg and that leg. Okay, it actually has a long resistor spread out in that form, like a horseshoe, right? And then on that resistor, there's a wiper that actually pushes on the resistor. So depending on where this knob is turned, the wiper is either over there or over there or over there or over there as we rotate it. Okay? And so the resistance between that point and that point, okay, is divided by this middle wiper into two resistors. The resistance from that point up to where the wiper is, and the resistance from where the wiper is down to the other side. Okay? Now, if we connect a potential difference or a voltage to this resistance, positive 5 on that side and 0 on that side, okay, then all the way along the resistor, we are busy dropping voltage. Okay, we start out at 5, we go 5, 4, 3, 2, 1, 0, because we connected this side to 0, right? Connected that side to 5, 5, 4, 3, 1, 2, 0. So that then divides up the voltage between the two pins. It gets divided depending on where this potentiometer wiper is. Okay, so because our wiper is connected to that pin and our wiper sees 5 volts, 4 volts, 3 volts, 2 volts, 1 volt, that wiper itself will be, depending on where we've rotated this, that wiper will be at 5 volts, 4 volts, 3 volts, whatever, as we rotate it. Okay? Fine. That's how a potentiometer works. And loosely speaking, people refer to it as a volume control. That's exactly how a volume control works. It takes the total volume that's available in your amplifier, and you can turn it down so that you go from 5, 4, 3, 2, 1, 0. Same principle. Okay, so now I want you to plug our potentiometer into your board. So we're going to plug him in there. Okay, 3 legs in the holes, and of course everything in that row is connected together. Everything in that row is connected together, so we can make a connection to these points of the potentiometer. And so now what I'm going to do is I'm going to connect the one side of the potentiometer. Let's go for black. Okay, I'm now going to connect the one side of the potentiometer to the ground rail. Okay, so I've connected that side of the potentiometer to the ground rail, and I'm going to connect the other side of the potentiometer. Let's go for white, and I'm going to connect the other side of the potentiometer. I'm going to connect to the positive rail. Now the potentiometer has a resistance of 5,000 ohms, so it doesn't matter that we have positive to the one side and to the negative to the other side. This is not a short circuit. It's got a lot of resistance in there to stop us having a short circuit. Okay, so now I'm going to connect my red jumper, which I've connected to pin 2 over there, right? I'm going to connect that to the middle point of our potentiometer. Right, let's see what happens. I'm now going to turn the potentiometer and watch the serial monitor. Okay, I turn this down, so I'm turning the volume down. I now get 0. Okay, why? Because my wiper is close to the 0 side, the ground side of this potentiometer. Okay, so now I can turn it up again. Okay, and now it's 1 because my potentiometer is here close to the 5 volt side. But you notice what happened. It didn't change at 0 and at 5. We actually could rotate it until it actually flipped. There we are. We flipped, right? And so from that point on, if I now rotate it further, from that point on, I'm going to be 0. Okay? And so this then shows you how everything from 0 volts up to whatever this voltage is, which is about 2 volts, anything between that value, 0 volts and that value, which is about 2 volts, is 0. From that value on, it now becomes 1. So everything below that value is 0, everything above that value is 1. And that's how the input of the Arduino Nano, that's how the input works. It looks, and if it's below 2 volts or whatever, then it says 0, and if it's above 2 volts, between 2 volts and 5 volts, it says 1. Okay. Now we're going to have a look at something else. Load for me BrightSparks pull up. Okay, and we're going to take out our potentiometer and take out these jumpers. Maybe zoom out a little bit. Come on, focus for me, please. I'll have to manually focus, sorry. Okay, so now I want you to plug in one of these. Okay, this is our little switch, right? So we're going to plug that in from the ground to somewhere else. Okay, fine. And I'm going to put my connector, my jumper, connect that to the switch. Okay, so now we are going to And actually I must go back to number 13. Apologies. I've gone too far, too fast. BrightSparks, number 13. Okay. Fine. So now I'm going to use that switch to send, to ask my Arduino to differentiate between the switch pushed and the switch not pushed. So I'm just going to load this up into the Arduino. Here we are. And we're going to run it. So we're going to switch on our serial monitor, and we have a whole lot of zeros, right? If I now push the switch, still have a whole lot of zeros. Let it go, still have a whole lot of zeros. Okay? Now why is that? It's because we are connected to ground, but when the switch is not pushed, there's nothing to pull this away from ground, so it just stays at ground. Okay, and then of course what's right happened at that moment, just due to something floating around in the air, it's gone to 1. And in fact, I can actually change that just with my finger. Change it to 0, change it to 1. So it's going to be very undefined as to whether it's 1 or whether it's 0. Okay? And the reason is there's nothing really pulling this nice and up to positive rail when the switch is not pushed. When the switch is pushed, yes, then we want it pulled down to 0. That's exactly what we want. But when we let go, we want it to go back to 1 because the switch is not pushed. And to do that, we use the next program. And so we go load sketch, BrightSparks, pull up. Okay. And this is identical to the previous one, except for one detail. We have defined this to be an input, but we said, actually, we'd like you to pull this up to 5 volts if I'm not pulling it down to 0. Okay? And that's what a pull-up does. A pull-up doesn't stop you pulling it down to 0. It says, when you pull it down to 0, it's 0. But when you let go of pulling it down to 0, I'm going to pull it up to 5. Okay? So now let's look at let's load that sketch into the Arduino. Right. Look at our serial monitor. Okay, there we have a whole lot of 1s. Why? Because the switch is not pushed. So the pull-up has pulled it up to 1. If I now push the switch, we go to 0. Okay? Let go of the switch, go to 1. Pull down, go to 0. So when we have only one direction that we're only pulling it down to 0 and not letting it go up to 5 volts, or nothing in our circuit goes up to 5 volts, then we started off with, and we initialize it not just as an input, but as an input with a pull-up. And then everything works honky-dory. We can press our switch and let go, and press and let go. And we are reading that press and reading its value into our digital value. Right, now we go to our next thing that we're learning. We're going to switch off the serial monitor, and I'm going to go load BrightSparks analog input. Okay, So up to now we worked with digital, right? Now we're going to start working with analog. Okay, and what's the difference in digital and analog? Digital has two values for every bit, a 0 or a 1, a 0 or a 1. Whereas analog can be anything between the lowest value and the highest value in steps of whatever. So for instance, we can have an analog signal that is between 0 and 1024 in steps of 1, right? That's typically what our Arduino Nano reads. And so voice is analog. The output of a microphone is analog. The amount of blue and green and red on your TV screen at any one point is analog. It goes between two values and can take on any value in between those two values. Fine. So let's have see how we can actually read an analog value. And now we had an analog here with our little potentiometer, right? Let's put him in the other way around. Okay, so remember I said between the one pin and the other pin there's voltage being dropped all the way along, and so the middle pin, the wiper, actually has somewhat the voltage depending on where this has been turned, somewhat the voltage between that, and that's very typically of something analog. So I'm going to connect again, going to connect the bottom pin to our ground rail, and I'm going to connect the top pin, even though I see on the screen it's top is bottom and bottom is top, but I think you can handle that. So that pin goes to our plus rail, and then the one that we want to read comes from the middle pin. Okay, and we plug that in, and now if you look at your Arduino Nano, we can zoom in as much as we can, and you'll be able to see on your Arduino Nano from this side it's 13 and so forth, and then we find a 0. Sorry if that's not too clear on the screen. Maybe if we don't reflect as much, you'll be able to see it's a 0. Okay, fine. So we plug this value, this jumper, into a 0. And now what do we have on the screen? We have serial begin, just so that we can print out what we're reading. We initialize an integer I, and we say I is equal to analog read from pin A0. And then print it out to our serial monitor, and then delay a little bit so that they don't rush by too fast. So I'm going to upload this to our Nano, and now it's running already, so I'll open up the serial monitor. Okay, it's now at 971. Okay, so I'm now going to rotate this to the left, and as I rotate it down all the way to the bottom, we get 0. But you see we're getting different values as we rotate it. So I rotate a little bit and I stop, and that's the value for that voltage on the wiper. Go a little bit more, stop. That's the value for the voltage on the wiper where it now is, and so forth. And I can turn this all the way up. So my input is going from 0 volts all the way up to 5 volts. And when I'm at 5 volts, the value is 1023. So I can read in with my Arduino Nano. I can read a voltage in between 0 volts and 5 volts, where, of course, 1023 is 5 volts, so any guesses what 512 will be, right? So 512 is going to be 2.5 volts. So I know that that is about 2.5 volts there at the moment. And so whatever our device is generating, if it's generating an analog voltage between 0 and 5 volts, we have the methodology of actually reading that value, okay? Reading that voltage. Very powerful, very powerful. Okay, now, say for instance that from 0 to 5 volts is too much voltage. You know, my sensor, whatever it is only giving me from 0 to 1 volt instead of from 0 to 5 volts. Yes, I can connect it up, and then I'll have from a value from 0 to 200 or something like that, right? All very well, but I think we can do better than that. I still want to have a value between 0 and 1024, 1023, to be as accurate as possible, but I only wanted to measure from 0 to 1 volt. Okay, we've got a way to do that. So we go up here to open BrightSparks analog reference, 16 analog reference. Okay, and now we have an identical program except for this one line here. Okay, now if I make that default, okay, and I'm going to save that, and I'm going to look at my serial monitor, and I'm going to turn this down. It's 0 there, all the way down, and turn it all the way up again. And it's 1023 all the way up. Okay, that's exactly what we have at the moment. And of course, that's why it's called default. That is, if you don't tell it analog reference something, it's going to take that as being all the way from 0 to 5 volts is what we are measuring. But what if I change this to internal? Okay. Right. So what if I change that to internal? Then I can upload it. And I can now look at my serial monitor. And it's 1023, 1023. Right, now start turning it down. And there's no change. Ah, now there's a change. And we are at the end of the rotation. So if I now, I'm going to move it a little bit so you can see it turning. I move it just a little bit. And I'm at 1023. Okay, and all of this, all of that, all the way up to 5 volts, all comes as 1023. So I can measure between 0 volts and 1.1 volts if I wish. Okay? Very handy, very handy. And then it has one more thing. If you go and you look at your Arduino Nano right here at the end, third pin from the left, or from the top in your case, there's something that says ref. Okay, that's voltage reference. And if you now go and switch this to external, then you can actually put a voltage on that reference pin between 0 and 5 volts, and that will be your maximum voltage that it will measure. So if you put a 2 volts on that pin there, it will measure all the way from 0 to 2 volts. The full scale will be 0 to 2 volts, etc., etc. Powerful, hey? Very powerful. Right, now I want to show you the next and the last thing that we're going to do today. And so we're going to load open BrightSparks analog out. Okay, so if we had an analog in, we should have an analog out as well. In other words, we can have an output that will be not just on and off, but for instance for an LED, brighter and dimmer and all the way dim and halfway bright and so forth. In other words, an analog output. And the easiest is to show it using an LED. So I'm just going to take this apart. And we're going to take our 1K resistor, because now we're working with an LED with an output, and so we don't want to blow our LED. Okay, so there's our dropping resistor, or our current limiting resistor. And I'm going to now put an LED in there. And do you remember which way it goes? Goes towards the ground side. It's the flat part of our LED, okay, or our short leg. All right, so it could be just our short leg or our flat side of the LED. So I think I'm correct if I do that. There we are. And I've just used a blue LED. You can use your red LED, whichever one you like. Okay. Now, analog right only works on a few pins. Quite a few, but only on those pins. Pin 3, pin 5 and 6, and pins 9, 10, 11. Okay? And we'll write that down for you to remember later on, but it works on pin 3. Pin 3 is one of those that it works on. Just making sure I've got it in the right one. And now plug in my LED. Nothing, because I haven't uploaded the sketch yet. Now what does the sketch do? For I from 0 to 255, and now this doesn't go to 1024, this just goes from 0 to 255. So 255 is flat out bright, 0 is completely off, and everything in between is everything in between. So I'm saying for I going from 0 to 256, well, less than 256, in other words 255, right to pin 3, analog right, the value I. Then delay a little bit so it doesn't flash too fast, and then do it again. So we're going up from 0 to 255, and then we go down from 255 down to 0 again, and see our incrementer has become a decrementer from 255 down to 0. We write the value to pin 3 and delay a little bit. Let's upload. Now my camera is not very good. Its dynamic range isn't that good. So you can see the blue kind of getting bigger as it gets brighter. But and you see that last dim part as being the most noticeable. So what we can do is we can just go from 0 to 20, and from 20 to 0. Upload. Right, and we want to maybe delay a little bit longer now because it's flashing a little bit too fast. Upload. Right, so of course an LED is a very trivial example, but that's how, for anything that we need an analog value, a value between some other voltage and another voltage, typically between 0 volts and 5 volts, then we can use our analog right to do that. Now, actually how it does it is called pulse width modulation. And you don't have to know this, but it's interesting that when it is sending out a very low value, it just gives a little blip every now and again. And as this value gets bigger, it stretches that blip out. And so makes it longer. And that's why the actual LED burns brighter and brighter, because it's got more and more at 5 volts and less at 0 volts. That's basically how it goes. When you've got, the more you have spend time at 5 volts, the brighter it's going to be, and the more you spend time at 0 volts is the dimmer it's going to be. And using that principle, pulse width modulation, we can actually get a value. We just put a capacitor on that, and that will give us a voltage between 0 and 5 volts. Fine. That then concludes this lecture. I hope you enjoyed it.